Hello and welcome back. So far, we have built a multiple linear regression model and a polynomial regression model on our salary prediction dataset. In the first model, we have got around 60% accuracy. That's we said an underfitted model, and we made the model complex by doing a second degree polynomial. We have got 92%, around 90% accuracy there. We built two models, and one model is giving more accuracy than the first one, and we don't know whether that is the best model or not. So we may have to do some trial and error, maybe third degree, fourth degree, like that. And every time we do a trial and error, or we build a new model on the salary data set, we may be using our train set and building a model and testing it on train set and again testing it on test set. Initially, I said that until and unless we are confident that the model is going to work well on the train set, we are not going to touch test set, right? So to come to that place, or to do that way, actually we don't want to touch the test set until we are confident that the model will work on unseen data. We have some model selection approaches. So resampling techniques are those model selection approaches. One of the resampling technique is k-fold cross validation. What it does is, instead of we testing it on test set, it takes the train set and splits the train set into k number of folds or pieces. And here I have split it. In this diagram, the train set is split into 8 pieces: 1, 2, 3, 4, 5, 6, 7, 8. And the cross validation approach takes the 7 pieces and uses this data as train set and uses the 8th piece as a cross validation data set and builds a model on the trained data, and then takes the cross validation set and tries to calculate the accuracy or error metric. And then on the second piece, on the second iteration, the first iteration, it takes the first piece as cross validation. On the second iteration, it takes the second piece or second subset as the cross validation set, and then uses the other 7 to train the model and tests on the second cross validation. Like that, k number of runs it will do. If you split the data set into 8 pieces, it will do 8 runs. In the first run, these yellow 7 ones are going to be train set, and this green one is the test set. And the second run, the yellow ones are the train set, this green one is the test set. Like that, it will run 8 runs. So k runs it will do. Each time it will get some train error and some cross validation error. It is going to take the mean of all the cross validations errors and the train errors and keeps it aside. Suppose that on linear regression we have done the 8-fold cross validation. It will get one mean cross validation error and one train cross validation error. It will keep it aside. On second degree polynomial, again it will try to do 8 models and calculates the mean train error and mean cross validation error, keeps it aside. On third degree polynomial, again it calculates it builds 8 models and then takes the mean of all the train errors, right, in the first, second, third and 8 errors, and then keeps it aside. Cross validation also keeps it aside. Out of all these 3 sets of train and cross validation errors, it will see the best model, which one gave more accuracy on the train set and which one gave the equal amount of accuracy on the cross validation set, and then chooses that model as the best model. This is called as model selection approach. Resampling, one of the resampling techniques is this. Based on this resampling technique, we will try to build a model and show you an example, and then we will understand the other cross validation techniques also, or the resampling techniques also. Thank you.